Hello everyone, in the last video we reviewed Byte Stream and how to use Byte Stream to read from or write to a files, bytes by bytes. So in today's video we're going to continue from that. But before we jump directly to Character Stream, let's take a look at the Charset class, as it's sort of important component when working with text in Java. So especially we're going to go to the terminology here and we will take a look at a Charset definition, a coded character set, and a character-encoding scheme. A charset is defined as the combination of one or more coded character set and a character-encoding scheme. Let's talk about a coded character set. It is a mapping between a set of characters and a set of integers. So here we have US ASCII, isolating one, and Unicode are examples of a coded character set. Let's take Unicode as an example. So in Unicode version 16, we have 155,000 characters with the corresponding number of code points here. So this is the current number of characters in Unicode. And we're going to have Unicode characters. So basically a Latin alphabet, right? We have every character here have its own code point. So this is Unicode code point. So we see the prefix U plus, and this is the hexadecimal representation, and as you see decimal representation. So there's no two characters have the same code point. Each character have its own code point. So for example, we have character 8. This is code point character 8, character B, the code point character B, and jest, the code point of jest. So we have a Japanese character also have its own corresponding code point. And we have emojis, a fire emojis. So this is the code point of the emojis. So if we want to learn more about these characters, we can take a look at this link. For example, this link is for the fire emojis. So you can see here, so this is the code point 1F525. 1F525. Similar to the Japanese character here. So this is the code point 5301. 5301. Another important part that creates a charset besides coded character sets is the character encoding scheme. So a character encoding scheme is a mapping between one or more coded character sets and a byte sequences. So a character encoding scheme could be UTF-8, right? UTF-16, ISO 2022, and UC. So let's take UTF-8 as an example. So here we have a mapping between a character set and a byte sequences. So here's our character set, here our byte. So you see here, basically the UTF-8 is going to map our code point to an array of byte. So for example, we have the 8, this is the code point, and will be mapped to 1 byte. So this is the hex representation. Similar to B in jest, it also will be mapped to 1 byte. But for another languages, like for Japanese, their characters will be mapped to 3 bytes. And for emojis, so this code point will be mapped to 4 bytes, right? So emojis, and if you go to the encoding here, so we see the hex representation, and this emoji is F09F94A5, F09F84A5, and for the Japanese encoding, so we have E5AC81, E5AC81. Okay, so we noticed that UTF-8 is a variable length encoding scheme. It means that one code point could be encoded to 1, 2, 3, or 4 bytes depending on its code point. So another thing is the encoding schemes are often associated with a particular coded character set. So for example, UTF-8 is as an encoding scheme is used only to encode Unicode character set. It's like code point to byte array. So in the other words, if we use UTF-8 as an encoding scheme, the resource must be Unicode compatible. Okay, next, let's go to the rule to name the charset. So we know that the charset is a combination of coded character scheme and a character encoding scheme. So this is how we name the charset, right? So when we have a coded character set is used exclusively with a single character encoding scheme, then this charset is named for the coded character set, and otherwise the charset is named for the encoding scheme. UTF-8 character encoding scheme is used to encode Unicode only. So it dropped to the otherwise statement, right? So the charset this time will be named to UTF-8. So it means that the charset UTF-8 is using a combination of UTF-8 as an encoding scheme and Unicode as a coded character set. So in Java, this charset is represented as the standard charset of UTF-8. So whenever we're using the standard charset of UTF-8, we understand that we are using the combination of Unicode and UTF-8. So similar to UTF-8, in Java we can take a look at the other well-known charsets at the class standard charset. So we have US ASCII, we have isolating one, UTF-8 of course, and the other. We can create a charset. So if we don't want to use this standard charset, and our charset is, for example, out of this standard, then we can create it from the charset of phoneme. Okay, let's move on and do some experiment in our Java. So in Java, we can use UTF-8 charset to encode a string to byte array. So for example, if we have a string emoji here, we can use the string.getBytes and you specify the charset, like we're using UTF-8, and then we're going to have the emojis in byte array. And the other way around, from byte array to string, we can use new string and we specify the bytes with the corresponding charset. So you may ask, we're learning about mapping Unicode characters to byte sequences. Why don't we use character instead of a string? So the answer is because the character, the char primitive types in Java is not equivalent to a Unicode character. In Unicode characters, equivalent to a code point at its definition, we can easily write that by, you have emojis here, and if you are going to have a string here, and if you have a string of length, so usually you will expect that it's going to return 1, right? Because we only have one character here, but this time it's returned 2. So we only have one emoji character, but it's returned 2. So this 2 is actually a number of the cards, so like the size of the card array. So basically, this is equivalent to, you have a string and you convert it to a card array. And we have card array here. And if you card array of length, you have is 2. So one emoji character needs 2 cards, right? So it's easy to understand because one emoji is encoded to 4 bytes, right? Using the UTF-8, as you can see here. So the code point of the fire emojis will be converted to 4 bytes. 4 bytes. But in Java, the card primitive is only 2 bytes, thus can only represent a set of character from like 000 to FFFF. Is sometimes referred to BPM, the character. So if you take a look at the character documentation, the Java documentation, you see here. So the way that we're using, actually Java is using Unicode character representation for storing the Unicode. Okay, so how do we get the number of Unicode character here? So the answer is we're counting the code point, right? Because one Unicode characters corresponding to one code point. So here we have to call the code point function to get a stream of int, actually yes, a stream of code point. And we call count. So for example, we have one character, one emoji, fire emojis, then it's going to return 1. And for example, we have, one English characters, one Japanese characters, and one emojis. So if we use code point, we count on code point, it's going to return 3. So this is the number that we expected. Okay, so this is just a good to know. So if you want to dive more into Unicode, like especially about Unicode normalizations, then something like a normalizer, so the NFD, NFC, maybe you can search it somewhere else. Okay, then we just review some knowledge about cassettes, and let's move to reset our file Unicode character.txt with it. So the file Unicode character.txt contain like only 3 characters, like the English, the Japanese, and the emojis. So let's take a look at it. So just simple like this. And then we're going to confirm our concept so far by running step by step these files. Okay, let's go through it step by step. I'm going to put a breakpoint here. So first of all, we read all bytes of the Unicode of characters files. So let's go to the console to see. So by representation of the file contains 3 characters, right? And then we just bring the file here. So then we have file 8. So this is the byte, right? 1 byte, 2 byte, 3, 4, 5, 6, 7, 8, 8 byte. So we have 3 characters, but it's encoded to 8 bytes. So now we just confirm that how we do the same thing, we reach the same result in Java. So in Java we have 1 English, 1 Japanese, and 1 emoji character. So first of all, let's encode the English. So we are going to encode the English here. Then English, we get bytes, right, in UTF-8. So this is our English jest, and so this is the link of the website, right? And this is the where we convert it to the hexadecimal representation. Okay. Then now we're going to get the byte, and we bring the byte. Bring the byte here. So you see, this just encode that to file 8. And the next one is we're going to encode the Japanese character. So similar, we had the current Japanese character will be encoded to E5AC81. Similar, the last one is the emojis one. The emojis also be encoded to like F0, 9F, 94, A5, right? So basically, they are the same with the file, like the byte representation of the file. If you take a look at the file, for example, if we have a file name is the Unicode, right? Unicode. So you see the file also is using the Unicode as the encoded character set and UTF-8 as an character encoding scheme, right? So basically, it should be the same if we do manually without character. Okay, so let's see what happened if we we decode byte by byte. So now we are going to decode the file this byte by byte. So for example, if we are going to decode the file like file A to a character, E file to another character, AC to another character, just decode byte by byte. So we will end up with just it's not really a character, right? So the system cannot recognize that. So we have to know exactly, like for example, if we know it's a jet, like the jet English, the English characters, then we should only use 1 byte to decode it back to the character, right? So for example, I get 1 byte, one first byte from the file, because I know we only need 1 byte to decode it back to the English, and that's why I have the English byte. And for the Japanese, I know for Japanese, and it needs 3 bytes. So that's why from our byte array, I take 3 bytes, and I'm going to convert it back to Japanese here, right? Using the new operator here, and with a Japanese byte, and using the UTF-8, right? Similar to the emoji, I needs 4 bytes. Okay, 4 bytes here. And the last one, so basically we don't have to know, right? So the last one, we have the older byte here, and we just asking Java to convert older byte to a string for us, and encoded by the UTF-8 here. Okay, now you may ask, if we only play with bytes, so how do we know we should get the next how many bytes to enough to decode back to the character, right? So actually it's like a algorithm of UTF-8. For example, the UTF-8 have this one. So for example, if your byte start with 0, so then we know that it's only 1 byte needed to be decode back to the character. So if you receive the byte that start with 110, UTF-8 will understand that it will need 2 bytes to decode it back to the character, and the second byte should start with 10, similar to the 3 byte and 4 byte. Okay, so let's use our 5 emojis. So 5 emoji, right? So 411110. So because it's 11110, so the UTF-8 understand that okay, it needs 4 bytes, so it needs more 3 bytes plus the current byte 4 bytes to decode it back to the character, and these next 3 bytes should start with 10. So basically 10, 10, 10. So that's the way that the UTF-8 work to encoding a character to byte and decoding them back. Okay, back to our README. So not that in Java 17 and before, so the default cassette was the platform's default cassette, but in Java 18 it was set to UTF-8 as a part of JEP 400, UTF-8 by default, right? This is the JEPs. So this means that most Java APIs will use UTF-8 by default for character encoding and decoding. So unless you explicitly specify a different cassette. Okay, so here I'm using Java 21. So Java 21, right? So basically the get byte and the get byte will result the same. But in reality, it's always a good practice to explicitly specify the charset to ensure the correct encoding and decoding. So let's do the last demo that I I'm going to remove all of the standard characters, and let's run it again. So you see the results are still the same. Alright, that's pretty much just for this video. I hope you got something new out of it. Thank you so much for taking your time watching this video and the series. And as always, see you next time. Happy coding!